Okay, let's go. Number 3, part A. I wanted you to simplify or you express as positive in index, and we have 3. We had 3 8 power negative 4. 3 8 power negative 4. 3 is a constant, so it is 3 multiplied by 8 power negative 4. So you can simply deal with this 8 power negative 4, and when you express it as a positive index, it will be 1 out of a to power 4. The power becomes positive, and then you divide it over 1. You get 1 over it. So 3 to power 3a to power negative 4 will simply become 3 times, this one is 1 out of 8 power 4, we agreed last time. So it is 3 times 1 out of 8 power 4. And finally the answer is 3 out of 8 power 4. Many of you passed this, and I was happy with that. Let us look at another part B. Part B, when you look at it, we have a to power negative 2. Then again to power negative 3. The best thing we had to do here was to realize that we have 2 powers. One of the powers was a to power negative 2, and the other power was negative 3. So what we do in that case, if we have 2 powers, we always just multiply the 2 powers. So the answer would simply be a to power negative 2 times negative 3. When we have 2 powers, we just multiply them. And a negative multiplied by a negative, it gives us a positive. So the answer here was 8 power 6. Now, we had also 1 out of a to power negative 2. So this is division, so we can simplify by saying this is 1. You divide it by 8 power negative 2. But you remember 8 power negative 2 is the same as it is 1 out of a squared. Just a minute, someone is disturbing me on phone here. Hello? Yes? Here at main campus in SETA. You have talked to your dad? But you talked to him, because he was going to ask whether main or primary, but just come to SETA. Sorry about the interruption, but let's continue. We have 8 power negative 2. 8 power negative 2 is the same as 1 out of a squared. 1 out of a squared, and 1 out of a squared. When we are dividing by fractions, we multiply by the reciprocal. When we are dividing by fractions, we always multiply by the reciprocal. So this becomes 1 times a squared out of 1, which is equal to a squared. Again, many of you passed that. Those who handed in, that was good. Part D, I had given you a to power 2, then b to power negative 3, remember, and all of them had a power of -1. The best thing to do was to multiply this power of -1, put it inside and multiply by the powers inside, because you know when you have two powers on a base, you just multiply the two powers. So this one gives us 8 power 2 times -1, this -1, then times b to power -3, again times -1. So 2 times -1, the answer is 8 power -2, and b -3 times -1, the answer is b cubed. So 8 power -2 becomes 1 out of a squared. You remember, the power is negative, so it is 1 out of a, then you change the power to squared, so it is 1 out of a squared times b cubed. The answer ends up being b cubed out of a squared. I think that one there was no problem with that. Number 2, most people who handed in passed it. I told you the easiest way to do these numbers, when you realize that the denominator of the power here is 3, you know that that number you are dealing with most probably has a cube root. Know that that number most probably has got a cube root. So you can express the 8 in terms of its cube root. And 8 is a cubic number. There is a number which is multiplied 3 times to get 8, and that number is 2. So 8 is 2 to the power 3. Then there is another power which is 2 out of 3. But when we have two powers on a base, we usually multiply the two powers. So this becomes 2 to the power 3 times 2 out of 3. 2 to the power 3 times 2 out of 3, and the 3's will cancel, so you end up with 2 to the power 2, whereby the answer will be 4. Most of you passed it. I was happy with that. Part B, we have 32. Now, look, the denominator, the power, on the power, the denominator is 5. Most probably this 32 has got a number which is multiplied 5 times to get 32. And the number is 2. If you express 32 as a product of its prime factor, you are going to realize that 32 is 2 to the power 5. So if 32 is 2 to the power 5, we write 2 to the power 5 instead of 32. And now the two powers become 5 and 2 over 5. So we multiply the powers. Multiply the powers, and our answer becomes 2 to the power 2, which is 4. However, many of you got a challenge with this question, but there was nothing hard. How easily could you have done it? Check my working. Now, the power here, when the power is a fraction, it means the denominator, if the denominator is 2, it means the number, the base, has a square root. If the denominator of the power is 3, it means most probably the base has a cube root. If the denominator of the square is 8, then there is a number that is multiplied 8 times to get the square. So then the denominator of the power is 2. So it means 81 has a square root, a number that is multiplied 2 times to get 81. I could have used 9, or I could have said 81 is 3 to power 4. Or I could have put 9 squared such that the squared cancels with the 2. But I chose to do it like that, which is still okay. It will still give you the same thing. So I expressed the numbers in terms of their prime factors. 81 is 3 to power 4. 64 is 2 to power 6. You agree with that? You can confirm. So that means I'm going to have 2 powers on the base. The power here is 4, and there is another power which is negative 3 over 2. So I will have 3 to power 4 times negative 3 over 2, like that. Then 2 to power 6 times negative 3 over 2, like that, which is the power up. And by 4, I mean by 2, this is 1 by 2, this is 2. By 2, this will be 1 by 2, that will be 3. So I have it as 2 to power negative 9. Then again, when I reach this stage, I remember that 3 to power negative 6 is the same as 1 out of 3 to power 6. And 2 to power negative 9 is the same as 1 out of 2 to power 9. So finally, I have 1 out of 3 to power 6 times 2 to power 9. And this ends up being my answer. So those who did the work correctly, I want to thank you. You were following what I was explaining. Any question before we go to another part? Anyone with a question? Joshua, I didn't see your work. Sarah, you submitted your work late. Gideon, I didn't see your work. Antonio, I didn't see your work. You people, what was the problem? Okay, it seems there is no question, so let us continue with our work where we had stopped. Remember this work of indices, I told you it starts from page 52. So page 52 is here, and last time we had stopped at page 57. This is where we stopped. Yes, I remember we are saying if you have like 36 to power a half, you remember that 36, if the power is 2, the denominator of the power is 2, remember that 36 will have a number that is multiplied 2 times to get it. So instead of writing 36, we write 6 squared, like that. That one should not be a problem. We looked at that work, remember. Maybe today we can start from these examples. Can start from these examples. Gideon, Gideon, I have a question for you. I think this is what you have just done. So let us continue and look at these examples. We have the first one as y to power a half times y to power negative a third. Who can tell me how we can approach this? How should we do this one? Y to power a half times y to power negative a third. Who can give us an idea? Sarah, what do you think?
I think we shall say y, then you add a half plus a third, plus negative 1 out of 3.
We say y. What is y? I want you to say that y is the base and the base is the same, right? The base is the same, it is y. Eh? So since we are multiplying indices that have the same base, we write one base which is y, and then we add the powers. So we shall have y to power a half plus negative a third. Eh? Y to power a half plus negative a third. Now, to get a half plus negative a third, a positive followed by a negative, the answer becomes a what? A negative. So it ends up becoming a half minus a third. And a half minus a third, if we do it aside, as our side work there, all of us, a half minus a third, it will give us the LCM as 6. Then 6 divided by 2 times 1 is 3. So 6 divided by 3 times 1 is 2. 6 divided by 3 is 2. So it is 3 minus 2 out of 6. So the answer is y to power 1 out of 6. If we do it as side work, from a side all of us, a half minus a third, the answer is y to power 1 out of 6. I think we agree with that. Let us go to part B. Now, part B, I want us to do it from our side work in our revision book there. We are going to say 5 to power negative a half times, now we open bracket here. Said we are doing it from a side as our side work there. 5 to power half negative a half, then times. Now 20 is 5 times 4. Okay, 20 is 5 times 4. Those are factors of 20. Now you try to use a factor that already has 5, which we have here. So 20, we are going to say this, we open bracket and say 5 times 4, then we close bracket, and all of it is power a half. I don't know if you are getting me. 5 to power negative a half, then you multiply, open bracket, 5 times 4, close the bracket, all of it to power a half. Now that one that you have put in bracket, let the a half come inside the bracket to be a power of everything. Now there is no only one method of doing indices. For example, what is here is another method. What is here is another method, and what I was telling you is also another method. So you continue with the one that I was telling you In the second step, when you open the bracket, you are going to have 5 to power half times 5 to power a half, then times 4 to power a half. If you have done that, 5 to power half times 5 to power negative a half times 5 to power a half, the base is the same. We write the base, which is 5, then we add the powers, negative a half plus a half, and the answer there is 0. So we have 5 to power 0, which is 1. And the other side, we have 4 to power a half. 4 to power a half is 2 squared to power a half, whereby the 2's will cancel. The 2's will cancel, so the final answer is 2. So what I have been telling you is another method, and here there is also another method. Which method are we having here? 5 to power negative a half times 20 to power a half. Now 5 to power negative a half, I think you agree that this is the same as 1 out of 5 to power a half. By the way, 5 out of 5 to power half is the same as 5 out of 1 to power a half. So if you want to change the sign of the power, just take the reciprocal. So 5 over 1 to power a half, to power negative a half, is the same as 1 out of 5 to power positive a half. You change the sign and take the reciprocal. So that gives you 1 out of 5 to power half times 20 to power a half. Now, since these two have the same power, I can put them in brackets together as 1 out of 5 times 20, all of it to power a half. And 5 times 1 out of 5 times 20, the answer is 4 power a half. There should be some questions here. I don't know how many of you used the method I was telling you that we are doing together here. The problem is that you don't ask questions. Please, I'm trying to move slowly. This is your lesson. Ask questions and understand. Yes, sir.
I didn't understand that first method.
The one I was talking about, or this one that we have on the screen?
The one you are talking about.
Yeah. Okay. Let us 5 to power. We have 5 to power half. Let us do it again, all of us. We have 5 to power half, to power negative a half, which is this. I'm saying where there is 20, we put there 5 times 4 in bracket. So it is 5 to power negative a half times, open bracket, 5 times 4, then to power a half after closing the bracket. Now, since the a half as a power is outside the bracket, so it is the power of everything inside. So it will now be, we write the next step, 5 to power negative a half times 5 to power half times 4 to power a half. Now, when you do that, you realize that you have 5 to power negative a half times 5 to power half, where the base is the same. So you write one base, which is 5, and you add the powers, negative a half plus a half, which is 5 to power 0. Then you multiply by the 4 to power a half. So any number to power 0 is 1, so you'll have 1 times 4 to power half, and 4 to power half is the same as 2 squared to power half. And the final answer, 2 squared, 2 power 2 times a half, and the final answer will be 2. I think you have got it now.
Yes.
Okay, let's continue. We have 8 to power half divided by 12 to power 12a to power 5 over 2. Now 8a to power half is the same as, we can put the division and say 8a to power half divided by 12a to power 5 over 2. Now I can simplify by collecting like terms, those with a together and those without a together. So the dot here means multiplication. It is not point, yeah? The dot means multiplication. It becomes 8 out of 12 times. Now, we are dividing indices now which have the same base. We have 8 power half and 8 power 5 over 2. So we write one base, which is a, and we subtract the powers, a half minus 5 over 2. And the answer will be now 2 over 3, 8 power. 1 minus 5 is the negative 4 over 2, which is negative 2. So this ends up being our answer. Then when we simplify it, remember 8 power negative 2 is also the same as 1 out of a squared. So we have 2 out of 3a squared. So tell me about that. Is there anything that you have not understood on part C? Is part C okay? Is part C okay?
So what's the dot?
Dot, I said dot means multiplication in mathematics. Okay?
Okay.
So dot means multiplication. This is a multiplication sign. So it is 8 out of 12, this one, then times a power a half minus 5 over 2. Even here, now this one reduces to 8 power 2, so it will be 2 over 3 times 1 out of a squared. Now, we are going to look at indices where there is an equal sign. How do we deal with that? Now, if we have the same base on opposite side, if we have the same base on opposite side, then the base can cancel and you equate the powers. What I'm saying, for example, this is 3 to the power x. If I have the other side also, and I have there 3 to the power 2, then the bases will be the same, they will cancel, and you remain with x equal to the other power, which is 2. Now, for example, if you look at this, we have 3 to the power x. We have 3 to the power x. We have 3 to the power x equal to 243. What we do, we express 243 in terms of in terms of 3. When we express 243 in terms of its prime factors, it is the same as, can you tell that I'm still in a lesson? Can't you wait? So 3, this becomes 3 to the power x equal to 3 to the power 5. 243 is 3 to the power 5. So what I was telling you, the base is the same. Here the base is 3 and the base is 3. You only do this when they are equal signs. So the bases are equal, so the powers will also be equal. So you can cancel the bases and remain with the powers, so x will be equal to 5 in this case. I don't know if you get me. In this case, x will be equal to 5. That's what I'm talking about. Now, in part B, we have 2 to the power x minus 1 equal to 32 out of root 2. So 32, what we do, 32 divided by root 2, it is the same as 32. Remember when we are starting that time, we said root 2, square root of 2 is equal to 2 to the power a half. So that's why we are saying 32 out of root 2 is equal to 32 divided by 2 to the power a half, which is 2 to the power 5. 32 is 2 to the power 5. You divide it by 2 to the power a half, which gives us 2 to the power 5. Since we are dividing the indices that have the same base, we write one base, which is 2, and we subtract the powers, which are 5 and a half. So 32 divided, here we are dealing with 32 divided by square root of 2, and it ends up becoming 2 to the power 5 minus a half. So 32 is 2 to the power 5 divided by square root of 2, which is 2 to the power a half. So the bases will be the same. We write one base, which is 2, and subtract the powers, meaning that now our 2 to the power x minus 2 will be 2 to the power 4 and a half, meaning the bases are now the same, so we only write x minus 1 equal to 4 and a half, and we solve for x by taking 1 the other side to be added, and our x will be equal to 5 and a half. Now x to power negative 3 out of 4 equal to 27. It means x to power negative 3 over 4 is equal to 3 to the power 3. Is equal to 3 to the power 3. We are saying we can make the power of x to be 1. We can make the power of x to be 1. This can be done by multiplying both sides by negative 4 over 3, which is the reciprocal of negative 3 over 4, which is this one here. So what can we do? This can be done by multiplying. Now alternatively, what we can do here, we can also say we can change this power to be a positive. The easiest thing to do is change this power to be a positive and say this is 1 out of x to the power 3 over 4. Then you cross multiply. You cross multiply. So for today, we are going to stop at page we are going to stop at page 58, and these first two examples of page 59.